Hello and welcome back to another Physical Sciences 3 lecture. So in this lecture we are now looking at the formation of ions, and we know that an electrically neutral atom will have the same number of protons and electrons. Okay, so you have the same number of positives as negatives. All the elements existing in a chemically uncombined form are electrically neutral. A piece of shiny metal, zinc, Zn comprises atoms possessing 30 protons and 30 electrons. Although not normally done, we could indicate the neutral electrical charge by writing the symbol as Zn and then with the power of 0, indicating it is a neutral charge. Atoms want to form a stable electron configuration. One way atoms can gain a stable electron configuration is to lose or gain electrons. When atoms lose or gain electrons, they then have an overall electrical charge and are called ions. A neutral atom gaining electrons results in a negative ion called an anion. For example, if we have a chlorine atom and we add an electron, we get a Cl-, so a Cl ion, which means we had 17 protons and 17 electrons to start off with. Then we had 17 protons and 18 electrons, so it becomes a negative charge, and we put the little negative charge to the power. It's like saying -1. A chlorine atom has 7 valence electrons. It requires 8 valence electrons to attain a stable electron configuration. It therefore gains an electron and becomes an ion with a charge of -1. Okay. All right. So we have a neutral atom losing electrons results in a positive ion called a cation. Okay. So positive is cats and ans are negatives. These are negative. So for example, if we have this aluminium, okay, it starts off with 13 protons and 13 electrons, but then if it loses 3 electrons to become stable, then we have an Al3+, so notice that the charge is put to the top and it's 3+, plus 3 negative electrons, okay, and these are like -1s, so e to the minus is like equal to E1 minus, like that. That's what we can say. So an aluminium atom has 3 valence electrons. It loses 3 electrons to gain a stable electron configuration. It is therefore an ion with a charge of +3+, as it has 3 more protons than electrons. Excellent. And that brings us to electron configuration. So the space around the nucleus of an atom occupied by electrons are referred to as electron shells, or energy levels. So typically in chemistry we refer to them as electron shells, or in physics we refer to them as energy levels. The electron capacity of the nth shell is given by the formula max number, so max no, or number of electrons, equals 2n squared. So for example, 2 times 1 to the power of 2 is equal to 2. 2 to the power of 4 is equal to 2 times 2 to the power of 2 is equal to 8, and so on. So we can put the shell number is n, and we put that into this equation here. Anyway, to find out the maximum number of electrons. While in theory the fifth shell can contain 50 electrons, no known element ever has more than 32 electrons in a given shell. Atoms are stable if they have a stable octet of electrons in their outer shell. So that means that stable octet, so that means that 8 electrons. 8 electrons in the outer shell means that they're stable. Okay. Electron configuration is a system of indicating how electrons for a given atom are arranged within these shells. This requires an understanding of subshells and orbitals, both of which are beyond the scope of this course. However, there is a simplified notation that ignores subshells and orbitals and simply indicates the number of electrons in each shell separated by commas. So, the electron configuration for an atom of oxygen is 2 6. Okay, so oxygen has 8, so it has 8 protons, and so we have the oxygen shells, so we could draw it if we have an oxygen atom and a nucleus, then we can have electrons, 2 like this, and then in one shell, and then on the next shell we will have and then we'll have negative electrons like this. So state the electron configuration for aluminium. Okay, so let's have a look at aluminium. Get our periodic table out. So aluminium, where is aluminium on our table? Here it is. So aluminium has 13 protons. So an atom of aluminium has 13 electrons as well. So then we'll start with 2. 2 will fill out the first shell. Then it'll be 8. Okay, and then 3. Because aluminium has Al has 13 protons. So 13 electrons. The simplified configuration can be easily written for the first 18 elements because shells 1 and 2 completely fill with electrons before shell 3 starts filling. However, from sodium, element 19 onwards, the higher shells start filling before the previous shell is full. For this reason, electron configurations for these elements cannot be written without an understanding of subshells and orbitals, and therefore, for this course, you only need to write configurations for the first 18 elements. That's nice, isn't it? And if another element's configuration is required, it will be given. So state the electron configuration for a magnesium atom and a magnesium ion. What atom has the same electron configuration as a magnesium ion? Okay, so let's have a look at magnesium. Go to the table, let's find magnesium. Here it is. Magnesium is 12, so it has 12 protons. Okay, so we can say that, what was it? Let's write it out in full, shall we? What was its mass number? Ooh. Its mass number is 24, so we could write magnesium. Magnesium atom is 2412 Mg. Okay, so then would have magnesium, we'll start with 2, and then 8, and then, so that's 10, and then we'll have another 2 in its outer shell. So this is the Mg atom. Mg atom, and then we'll go Mg ion is 2, 8, and so a Mg ion would be 24, 12, and it'll be Mg 2 plus, because we've lost those 2 electrons. So it'd have 2 more protons than electrons. And so what atom has the same configuration as a magnesium ion? Well, it's going to be element 10, neon. So neon atom has the same electron configuration as Mg2 plus. So that's the way we're going to write our magnesium ion. Okay, good. Ooh, don't want that going down. I can go back up to there. Excellent. Okay, so we'll leave it there and we'll look at the periodic table next time.